All right, well, good evening, and thanks everyone for coming out. I know it's halfway through reInvent. We're all pretty much exhausted. Hopefully not still too hungover from last night, so we can pick it up again tonight. But I appreciate spending some time with me. What we're going to talk about today is 5 steps towards a self-driving cloud. If you're expecting me to drive a car around the stage, you're in the wrong room. I won't be doing that. What we'll be talking about instead is how you can automate your cloud services to wrap your developers and your application teams, giving them a lot of freedom while keeping it safe for your organization. We're really trying to work out how to speed this up, how to make it go faster, how to make it go easier, and how to really keep it secure as we move with more and more speed. So I'm Nathan Wallace. I'm actually the founder and CEO of Turbot. We spend our entire life thinking about this problem, working with all sorts of large organizations on it. And prior to that, I was actually in one of those large organizations trying to solve it at scale. You can listen to me because, I've done CloudFormation stacks, running those, accidentally deleting the VPC underneath me while on the server inside it. You could listen to me because I've had to sit in front of the VP of security of a large organization explaining why that one little Windows server that was not inside the network even became insecure, and someone hacked it because someone did a stupid password, and then that became a reputation risk for us. So I've been through those sorts of problems and thought about it deeply, worked with our team on that, and felt that pain very, very acutely. And hopefully we can all work together to avoid it more in the future. So what we're going to talk about today is really, what does it mean to get towards a cloud that is truly automated? How do we get there? What are the challenges on the way? What does it, where are we now in all the different things we're doing, whether it's infrastructure as code, et cetera? Because we're making good progress, but there is a long way to go. And I just want to talk about that a bit, frame that problem, help everybody think about how you're tackling it, and how much more there is to do, but how much progress we've made. And that'll really come down to the concept of governance and how you can think about providing that safety around your teams and that acceleration of them. Or if you are one of those teams, how you can convince the rest of your organization to give you that freedom, and it really will be safe and secure. So as we've moved to cloud, away from our traditional data center, everything changed. It's become quite difficult and different how we have to manage that environment. We try to pretend it's the same a lot of the time just because it's easier to describe. So yeah, it's the same, just a bit faster and all that. But it really has changed the requirements on us and made life a lot more difficult in a bunch of ways. In particular, it's just so much more agile. I mean, we know this. We're here. Look at the new features coming out this week. There is so much going on here at such an incredible pace that you have to work out how you're going to embrace this for your organization and ride this rocket. You can't create services in competition with it. You will get beaten, right? You have to think about how you're going to do that faster and embrace those things at speed. The second thing is, and this is often an uncomfortable statement, but application teams really control the infrastructure now. Infrastructure has become part of the app, whether it's auto-scaling or whether it's running a Lambda function that does something, creating storage locations, moving those things around. Applications control the infrastructure. That's how they manage their costs. That's how they do things so quickly, right? It's no longer we give them a big fat server and with one CapEx and leave it there for 5 years, right? What it is now is a world of constantly changing. We have to work out how to empower our application teams with that in a way where they can do it faster and more safely. The second thing or point is that with all that agility, we still need to keep some control. And what even more challenging, those expectations have gone through the roof. Can you imagine not having encrypted data now? But in your traditional data center, that was hard to the point of being acceptable. You didn't have it. You have to meet those expectations. The new service comes out, you have to implement it. Otherwise, you're behind. And then if you get stuck, you're in trouble, right? So you've got to work out how you're going to meet those constantly evolving expectations, and they are higher and getting higher, and that is a fantastic thing. But it's not easy to keep up with. There's a lot to learn. I'm sure most of your brains are feeling fairly fried at this point after days of sessions already and announcements. But as we have all that agility of the infrastructure, we also have to work out how to make it real time. So not only do we have higher expectations, but we have to be able to do it instantly. When they create things, they have to be done immediately. We can't review it. If we have to have a meeting about it, it's not agile anymore. We lost cloud, right? The 10-minute server became the 6-week server like we used to have. So we've got to think about how to do that in real time. And frankly, that means it's got to be software. You have to move your operations towards software. Manual processes will always slow you down to the point where you've killed the agility. And it's really tough to think about that. That means launching a new server has to go from the point of choosing the server, getting the hardware, being provisioned, coming up, getting hardened, being patched, and made available to the user to log in within minutes. Otherwise, it's not cloud, right? And that's the same for all those different parts, whether it's storage, Lambda functions, etc. Now, to be able to achieve that level of speed and control, the only way we're going to get there is with clear, consistent, repeatable patterns, clear architectures, architectures that tie together all those pieces so that we get to the 10-minute server or the 5-minute Lambda or whatever you want to call. If you have to get approval for that IAM role that you're wrapping around that, then you are too slow. So we've got to constantly think about how that whole architecture works together to deliver that goal for the user. What's exciting about that, though, is as we've empowered those application teams, given them that level of control, we no longer have to play whack-a-mole of tickets or have their project managers yelling at our project managers, working out how we're going to get stuff delivered on time. We can just sit there and do it instantly. And that creates a whole new level of collaboration and partnership between your teams that is very transformative. When you're no longer a block or, oh man, you got to do that, it's more of a how can we do that together conversation. Everybody starts moving more quickly, right? Security's now at the table, working with you. Your operations teams are thinking about it. Your developers are there. And you can learn and evolve through those new services together. There's no other way you'll get there. How could a cloud team be expert in all of them, right? And application teams need that level of support. So really, it has changed the way we have to function as an organization. We call it DevOps, right? We work out how to do that together. But we think a really fundamental part of it is automating that governance layer, because that's what enables it to happen in the real time that we need. So what does it mean to have a self-driving cloud? What does a future vision of that look like, right? So let's think about a real self-driving car and start to draw some analogies. Hopefully we won't stretch it too far, and it'll make sense. The first thing that we usually take for granted when we think about self-driving cars, we all know that's an incredibly hard problem, right? Everybody's struggling with it. People are putting humans back in those cars to make sure they're safe, right, as recently as yesterday, right? But basically, with cars, we kind of take for granted that the rules and regulations are pretty well defined. Stop signs, traffic lights, etc. We don't even really worry about that. Compare that to the world of infrastructure. How well defined are your rules and regulations? Okay, there's NIST 853, there's CIS guidelines, there's PCI, there's HIPAA, there's GXP. You can choose which one of those you care about, and they're all generally the same, but they're also all pretty wordy. They're not totally specific, right? And each organization has different things you need to do within that. If you try and make all of your applications meet the most compliant thing, you slow yourself down to the point of doing nothing. So working out how we're going to define those rules and regulations in a sensible pattern is actually a really hard and unsolved problem that we happen to have as we think about a self-driving cloud. It's one we normally take for granted. Of course, once we have that, we want to lay out various infrastructure, roads, bridges. This is the stuff we're used to doing today. We get pretty excited about our automation, and it is really cool stuff. I mean, I was talking to a customer yesterday. They're using Athena with S3, with all those glue services. They're doing searching 7 billion transactions in 5 seconds, and they're kind of getting annoyed it's not a bit faster, right? That's what we take for granted for infrastructure now, and it's available to us. But we've got to work out how to build it. Where are the roads going to go? What type of bridges do we want? Right, what's our patterns of traffic? Of course, once that's up, there's operating conditions. Well, I have a direct connect, but it's going through a router and someone backhoed through the wire. There's all that sort of stuff affecting the way we're operating, and we need to still make sure it's safe and functioning correctly. So we have to struggle with that challenge. By the way, that's what a lot of self-driving cars are thinking about as their primary challenge. Well, we can do it, but it's hard in the snow, right? That's actually just another one of ours after we already had to solve things like rules and regulations, etc. There's the application itself, which we can now call the car for the purposes of this conversation. And then there's all sorts of sensors in that environment. What's the status of the traffic? What's the status of my car? What else is going on in the environment? The next one, SDOps, we think of that as software-defined operations. How can we empower that car with that self-driving unit that capability so the application knows how to move forward. It's operating in an infrastructure environment that's starting to look after itself. Of course, we're not in there alone. There's all the other applications in the environment. We all know what we're doing, but all of the people we're working with probably don't, right? And then there's also the actors, bad actors, good actors, other actors in the environment constantly trying to attack or make trouble for us. We've got to work out how to deal with all of that in real time. Meanwhile, in the middle of all that's the poor lonely driver or operations team trying to get through, avoid the potholes, make it work, and hopefully that's where our software-defined operations can really speed them up. Of course, the wrench we throw into it is that we don't have static roads that everybody else did. We don't have a few car manufacturers making really cool things. We say to the developers, lay your roads, build your cars, do it yourself, right? So we've not only taken a hard, undefined problem with all those different components, we've said to these people, go nuts, build what you'd like, let's see where you end up, innovate, do infrastructure as code, stand something up in the console. It'll be amazing. So they're running around like maniacs doing that. And we're not only trying to automate how they're driving on the roads, we're trying to automate how they're actually building the roads. So that leaves us with a whole bunch of work that we've had to do. And the question is, where are we now? How much progress are we making on this problem? We've framed it as a big one. I think it's a very worthwhile goal, but where are we? So here we go back to the standard for self-driving cars again, just gives us a nice framework to be able to talk through and think about, right? So we all started with a level of no automation. We click around a bit in the console, we think about what we're doing, we hope that it comes together. Frankly, that's where most of us start in cloud. And it's an incredible thing. I mean, the power of creating those VPCs or those networks for the first time, it is mind-blowing after you're used to wiring up servers and all that stuff in the background or data centers, right? Building buildings, digging holes. We have so much power there because it's now in the console and effectively it's automated behind us. But for our purposes, it really is just no sense of automation. We do a bunch of checking and stuff on that, right? But there's no automated remediation, right? Oh. Yep, you got a pothole there. It's like, okay, I've still got to drive around it. I've still got to fix it, right? So we're doing basic good things. These are amazing things, but they're just the start. They are monitored by humans. They're executed by humans, and the decisions are made by humans. So they're inherently slow. Once we get beyond that, we've just got tools like CloudFormation, Terraform, Ansible, Puppet, choose whichever one you like. But basically what we're able to do with those is start defining infrastructure as code, laying out a path forward. But what are those tools doing? They're saying, please human, tell me exactly what you want. Please human, tell me when to execute. Oops, I don't roll back in the face of errors. Please human, correct me. Great. So these are done on decisions by humans. They're executed by a human at a time, and then they go through that way. For this, I apologize. For those ones that are executing by the system, we're telling it what to do and it's doing it. I got that wrong. So they're moving through that way. Service catalogs are similar. They're great blueprints. They accelerate some stuff, but they're still very manual. Tell me what to do when. We've gone even further, though. We've got these amazing things, events flowing through, running Lambda triggers and capabilities like that. So at this point, we've started to get to the point where it's being monitored by the system and it's being executed by the system. I still define this, though, as human decision because typically they're very fine-grained, quite hardwired, and they have a lot of fixed nature to them as they get deployed because they're hard to do with a lot of flexibility. So we've got to some partial autonomy, making good progress. Once we jump below the next line, though, we're getting to a place where the automated system is approving more and more of the changes. So we no longer have to have someone deciding what to do all the time. Autoscaling, I think, is a beautiful example of this. Your servers are getting busy. What's my threshold? That's my threshold. I'm going to keep adding more capability, more capacity. Right, scale up to meet it, then I'll scale back down. The system is monitoring, the system is executing, and the system's making the decision, according to rules, but the system's making decisions for what to do. Right, and now we're getting more and more predictive in that type of scaling, so the rules are less and less, more and more fuzzy, and the system's taking more and more responsibility. But it still only applies to some modes. EC2 servers, containers, maybe some Dynamo, right? We're gradually building up that capability, but it's quite limited, quite restricted. Now, what we've often focused on at Turbot and others are starting to do is basically guardrailing. How do we build more and more and more of these rules? How do we think about that whole set of rules and regulations and automate the entire suite? For example, we're at 1,600 policies now. Right, that is a lot of stuff. Taking all of those different standards and starting to document those and define those is a huge, complex task with a lot of interaction, right? But those guardrails are really now starting to define, okay, in this situation, I'm looking for this event, I'm looking for this configuration, I'm going to take this action to automatically remediate it because that is my policy posture. I don't mind how big your server is or what it is, but it's going to be patched. I don't even necessarily mind if you're running Red Hat or Ubuntu, but it's going to be patched. It's going to be hardened. And when you log into it, you're definitely going to be active in my directory. Those guardrails give us more and more modes of operation with more and more complex cases that don't have to be as predefined or as specific. They go much more flexible. To be honest, though, we're still really in a place where we're thinking mostly about the infrastructure. But the applications really need to start thinking about how they're going to be more autonomous in their operation of themselves, right? And we're doing that a bit with autoscaling and stuff like that. But what is the state of my data? What is the state of this? How do I run tests on myself in real time in production? How do I guardrail myself, making sure that I'm in good shape and continuing to improve? And we think that's more and more what full autonomy would look like. How to teach them to do that, of course, is an incredibly complex thing. So 5 levels of autonomy above the level of none, right? These are the steps of the journey we're on. And I think we're making great progress, but we're also still very, very early. We're still very, very directive in what we want things to happen. Because of that, we're often slow to respond at those levels, and it makes it expensive to manage. We're not killing the ticket, we're responding to tickets and dealing with those tickets and resolving those tickets. We never want to see those tickets again. We want automation to take care of that for us. Checking is a good thing, but it's not sufficient, right? We've got to get out of human review of those and get into, okay, this problem happened, this is what I'm going to do. What we often see happen in these environments is level 1, level 2. Well, we're going to outsource our level 1. To outsource our level 1, we have to have a playbook, right? If it's a well-defined playbook, we go through it. Half the time that playbook ends up saying, please call the app team. So we need to work out a way to take more and more of those decisions without having to ask, right? Nearly out of space, let's clean up the temp drive. Can I reboot the server without asking? Right? We can do more and more of that through automation. Humans slow it down. Agility is the key. So we've got to do more and more of that. One of our challenges with infrastructure as code is it's very, very fast to get started, but it's hard to maintain ongoing. You have to be very, very structured. You have to tell it what to do all the time. Right? You have to tell it exactly what to do, when to do it. You can't change it out of band. Maybe it'll detect drift, but it's very, very difficult to do it in a way where it's constantly ensuring it. So that brings us to the concept of governance. And how do we think about bringing all of that together? The first thing we believe in the world of governance is we have to give freedom. Freedom to our application teams, freedom to our developers. The second thing is we've got to wrap them with appropriate rules and regulations to keep everybody safe. Give them infrastructure to make them faster, easier, things that will accelerate what we're trying to do, and finally protect them. The first thing is you absolutely have to give self-service to these teams. You have to have console access. They have to have API access. You can limit their permissions. But you need to give them the ability to run infrastructure as code. They have to have the native ability to run those tools. If you start abstracting them, you start slowing them down. It's okay to accelerate them with better patterns, right? But it's not okay to abstract them away. If they have to use a blueprint, they're slowed down, there's less flexibility. That could be a good accelerator. It's a good should. It's not a great must. You don't want to say to them, you have to use infrastructure as code. It's a good thing to use infrastructure as code. They should want to use it. But if they never have console access and they have to do it through that method, that's just another abstraction. And it's incredibly complex to work out how to do it if you have no chance to experiment or learn by actually making mistakes and doing it. So it's really, really critical to think about how you're going to enable them to use those different tools. That is what the cloud provides them. Otherwise, they go do the cloud training, they come back to your more automated environment, and they're like, I can't do anything, right? And then you don't have a cloud anymore. You do not want to centralize major pieces of functionality. The cloud's delivering all these services to you in a repeatable way. Oracle databases, as many thousands as you want in different things, containers rolled out. Repeatable automated patterns are a powerful thing that you can do now, but if you try to bring all that together into one service, you're slowing it down, you become the bottleneck. Ride the rocket of the cloud, leverage it as it keeps growing. To do that, you have to adopt a multi-account architecture. Create isolation around each of these different teams, do not bring them all together. We're seeing more and more services and patterns supporting this model now. Most of our customers run tens or hundreds of accounts, breaking things up. There are organizations out there running thousands. It's a very, very clear blast radius. There are challenges with networking and stuff like that, but it is so many advantages that it is really a model worth adopting. If you start, normally you start with one. You're working, a few people working in an account. Then you start moving some others in because the cloud looks pretty cool. You get a bit of a shared house. Of course, then you start bitching over who did what to the fridge or where the costs are coming from. So then often we'll wrench back the other way and do a hosted thing where we're going to control everything and we'll do it together. But of course, that slows everybody down. Everybody feels a bit awkward. You've got the bad uncle in the corner slowing it and making it hard. So you really got to think about how can we get to multi-tenancy, embrace the multi-tenancy of the cloud to your advantage. Creating all of those different spaces for your developers to work while providing a central core set of infrastructure and services that they can share. From a rules and regulations point of view, as I mentioned before, there are so many standards. They're generally aligned, but they're all slightly different. They're generally, directive, but they're not exactly telling you how to do it. Even just naming your servers can be a hard problem as you move to the cloud and they suddenly become ephemeral. So getting all of those rules and regulations worked out and defined is a massively challenging problem, and one that we actually spend a huge amount of our time working through. How do you group them into appropriate standards that keep repeating? Approved. Is this thing allowed to exist in this region? Is this instance type allowed to be used? Right? Active. Is this thing still being used, or is it an IP address that's no longer in service? Should it be cleaned up and taken away? Backup or data protection. How long does security need you to keep it? How long does compliance need you to keep it? How long does an application team want you to keep it? And how do we line all that up in a set of rules across all the different services? Configuration. Does this thing meet exactly the specification we want for it? Right, encryption at rest and in transit. Right, logging and audit. We have so many different things here we're working through. Just the name of every server, the name of every subnet, the way that those things should be tagged, the way they should be laid out, what should be your IP space. Every single one of these decisions to reach a world of automation has to be well-defined, well-documented, and implemented through automation. Every single one of those processes and pieces of paper we used to have in the background is coming forward to the world of automation. Right? So we have a lot to work through here, and it's a number of tasks to go through. At Turbot, one of the ways we tackle that problem is by thinking about a policy engine and having a set of rules that play down through the environment. So this is an example of an S3 bucket encryption at rest policy, which is set high up to just say, hey, for everything under this point, we should enforce the use of Amazon SSE for the encryption. Of course, we then have exceptions. There's the account where we really need to use KMS. So a should rule can be made to override a higher level should rule. It was a recommendation. Hey, you really should use SSE, but you don't have to. Right? This account said, okay, I really want to use KMS. They could have said, I want to use nothing. Right? But a lower level rule can override a should rule can override a should rule. So then we have the idea that you really, really have to have requirements. So actually, I didn't mean you should use it. What I really meant was you have to use it. And if you don't want to, you need to get permission from a core team. We expect every bucket in our environment to be encrypted unless a security team has improved it. That's a must rule or a required rule. Required rules, of course, beat recommendations. But you still need exceptions, so you can have a requirement that overrides or an exception overriding that higher level must rule. And of course, that can go further down where for one bucket you can override that again. So we think that as you get through all those rules and those definitions, it's really, really important to understand that you have to be able to support a robust system of exceptions. We happen to do it through a policy engine. Others choose to use version control code or different stuff like that. But you have to support exceptions or your infrastructure will not be able to scale to what the cloud requires. From an infrastructure point of view, laying out that basic nature of the cloud, you can use things like landing zones. They give you a good basis for how your configuration should work, how your logging buckets should work, how you want to set up your accounts. They're an accelerator, just like we mentioned before, infrastructure as code or Terraform. They're laying out that basic infrastructure for you. At Turbot, we believe there's way more than that in terms of how you have to define patterns that will scale to help you work. One of the things we do and try to define a common language around is the permissions model. How do we work out how to handle those 3,000 Amazon permissions that are growing every week? How do we do that in a way where we're setting certain accounts with a certain amount of permission to use different services? And the way we do that is by breaking it up into a hierarchy. So you can grant this user a certain level of access. We've defined a standard language there. Encourage you to take a similar approach. Super user, owner, admin. Standard language that works everywhere so you can have repeatable conversations. If every conversation ends up referring to a JSON document, life's going to be pretty slow, particularly after they get wildcarded down. The next thing is that we like to do that by service. So all of Amazon combining different things or Amazon S3. So we end up with definitions like AWS S3 admin, AWS EC2 operator, standard language that we understand what it means and it works across the environment. What we then do is apply that through the hierarchy so you can have cloud teams that have that permission across all the different services, all the different accounts, or you can delegate authority to your sub-teams. It's really, really important that you can delegate access so that they can have that self-service that we spoke about earlier. Now, whatever model you choose might be slightly different to this one, but the really, really critical point is that a key part of providing infrastructure to those teams is having clear language, clear definitions that work at scale in your organization, right? Work across different environments, different services, all sorts of things. So we use the same model for Linux permissions. Linux admin, Linux user, same language, right? All different services. The next thing we really tackled as an infrastructure definition point of view is networking. So traditionally we think of a public network or a private network. At Turbot, we analyze that even more and actually there are 8 subnet types that really matter and map them through the NIST. Here's the properties, that is how we define them. It comes down to what's their route to the intranet, what's their route to the internet, what's their route to AWS, which is kind of internet, but we can generally treat it a little special. And then how does the route tables get set up with the IP space and stuff like that. So I'm just going to break those down a little bit and get into the sort of detail that matters as you talk through it. So an isolated subnet really has no connectivity to anything. Kind of nonsensical, but NIST 853 likes to define what these are. So you do them for completeness. Of course, then you can have a restricted subnet, which basically means no internet access. Many organizations work that way. And you want to have a good definition where all the traffic's coming back to your intranet. Again, standard language talking through the different parts. Private subnet means you can come back via the hairpinning, but still get to the internet. A limited subnet will have access through private endpoints out to AWS. Limited with peering. Okay, now our things can talk without hairpinning. Public, we flip back the other way. So now it's outward facing, no access to internal. And that sets us up to do a DMZ, which is public and internal facing. Now we have a private one, which is routing the traffic internally, but accepting traffic from the outside as a DMZ. That's actually one of the more common patterns once you're going out external. It's more complex. Direct access now, so now we talk straight out to the internet rather than coming back hairpinning all the time. And direct via the public IP. You can even have, for HPC workloads, a completely independent subnet set. Now, all of that combines to give you a VPC peering with independent and direct subnets. There's all sorts of building blocks there that we just went through creating that. Now, that common language, though, is really setting us up for the types of conversations where someone comes in and it's like, okay, I need to use AWS for my service. It's like, okay, what network do you need? I need a DMZ, and we know what that means. It's not, I have a network definition in a Terraform stack or something that then has to get run once. Hopefully nobody changes it out of band, right? At Turbot, what we do is we guardrail every single one of these things so that they have complete drift detection. If even one route gets changed 10 seconds later, it is changed back. Because once you have these types of definitions, you need to make sure that they're constantly and always true. They're not just true at the point of deployment, but they're true ongoing. That's what an autonomous cloud looks like, is when it's constantly holding that position. It's the same as like hardening a server. The golden image, right? It's great until one person logs in with root, and then you really don't know much anymore. It's the same for your infrastructure. You need to constantly enforce it over and over and over again. Make sure that that drift is always corrected. So the way you create that protection in the environment is through real-time guardrails. And at a high level, basically that looks like you're getting events from things like SNS, moving those to SQS queue, applying your context and your policy rules to it so you can make decisions about what to do, and then automatically enforcing those in the environment. That, of course, is audit trailed so we know what change happened and how things went. So what I thought I'd do is show you a little bit about how that works for us and what that can actually mean in that environment. So at Turbot, what we do is actually break up the accounts so each user can log in and see their specific account. I might see two, you might see another couple, production accounts might be separate, but each user can see their particular environment. And that's how we start to restrict access. But you want your users to go straight into the Amazon console to take their actions. Single click, all tied back to an identity system from your directory structure. When they do that, they can use the console to take actions. For example, we can do the classic S3 and just create something like a bucket. So we've all done that before. We've created S3 buckets. What's cool, though, is that now it's watching and it's going to detect that event. And our guardrails are going to start to apply to keep it safe and make sure that it's in compliance with our policy rules for the environment. So if we go look at that bucket, over time, it's going to start picking up the different policies and properties. It's already picked up the access logging. I didn't set that. That happened automatically in the background. It's already picked up tagging. If I refresh again, hopefully it's got some more. Oh, versioning's been turned on. Default encryption's there. So if I go into the logging, I see it's logging to our best practice bucket that's set up in the background of the environment. Our users didn't have to be experts in that. If they're junior developers, they may make that mistake or not know. If they're a senior developer, they're not wasting their time doing it because it's automated to policy. In addition, we can stop ourselves from being able to change that. Okay, I'm not allowed to disable logging. That's a sensible restriction because we're enforcing it, right? So we prevent wherever you can, but sometimes you can't prevent, so you have to detect and correct. Now that's great for security, right? And that's an obvious use case for all these do, but automation goes so far beyond that, right? Setting tagging, for example, to bring down cost centers and all sorts of different information we want in that environment about who created it, when it happened, stuff like that. Just best practices that we normally would say to people, well, you have to tag it, right, and check for. You can automate all of this. So they don't have to worry about it and you know your environment is in control. If we come back to Turbot and head into the account, we can start to see that it picked it up and it recorded all the different things happening in the CMDB, including the differences. We can go to the controls tab for, actually we'll go for that bucket. And we can see in the controls all the different things. It's just checked for that bucket. Was the cross account on? What happened? Was the bucket approved to exist? right? This is the standard language we were talking about a moment ago. And we can see things like the tagging. And here what we're actually doing is recording that change over time. We think this is critical. Visibility into what changed. Otherwise, people start to think that it just changed underneath and with no knowledge. You can work out different ways to give that visibility. This is how we choose to do it. You can see that we raised the alarm saying that tagging wasn't correct, and then we went and automatically fixed it, and then we immediately closed the alarm. That all happened within the same minute. This is a ticket we never had to deal with because automation dealt with it for us, right? For each one of those, you really want to record what happened. You need to know the event that triggered it. You need to record how you made the decision, right, and what decision you made, so that security and compliance are happy with that, but also developers can understand what is going on as things change around them. If you don't tell people what's happening as you change it through automation, they lose trust. To implement those controls, though, it has to be done in accordance with that policy engine. So for us, that's where the policies tie in. So you can set policies, for example, like the tagging one, right, which has a template for different tags, pulling in stuff from the account ID or stuff like that. But many of the policies you actually want just a lot simpler and more human because JSON is difficult to deal with. For example, enforce enabled to Turbot logs. So what we saw there was the real-time creation of something that was automatically configured to meet the requirements we need as an organization. We didn't have to think about it, we didn't have to worry about it. That's S3, that's simple. Doing this across every networking, every route, every EC2 server, every instance, what's the name of every single thing? That's where the rules and regulations piece comes in and the scale becomes very, very large. If you're starting to write a few templates, if you're starting to write a few infrastructure as code pieces, if you're starting to wire up a few Lambda functions, pause for a minute and think about the scale that you're about to tackle and the real-time size you're about to have to handle with that. Think about where you're going with that DevOps over time so you can start to think about the tooling you'll need to really make it work at scale. I mentioned before the permissions piece. So what we do there is really bring in those permissions down through the hierarchy. So you can start to add grants by simply searching that AD system and then assigning permissions like whether it's AWS, ACM. See how the naming is consistent? Consistent naming is critical here, right? So people can really understand what's going on. We like to focus on things too, like automatic expiration of rights. Why do I need continuous rights in places like production? So if we think about that automated world, we talked about the challenge of getting from no automation, or now today we're doing some scripts, then we have some checking, we're starting to do some basic functions, right? If we can get to that world of full automation, what we're starting to unlock is a whole massive amount of speed, right? Safety that we have, beyond what we ever saw before, more accessibility. Your productivity of your junior developers will go up massively, your senior developers are better able to do things. Accessibility means more people can write this stuff because they're not going to make mistakes, or their mistakes are guarded. And then we have a breadth of coverage beyond anything that we're close to. Because once we're getting those tools and reusing them more and more, every account benefits from it. And the depth of thought we can put into each one is very, very powerful and a level beyond what we could expect any single application team to go to. How did that flip back? So to summarize, you're in a world that is both complex and real-time. That's way more than you've ever had before. You've got to work out how to deal with it. The second thing is that there are really 5 levels of autonomy to think about. We're basically hovering between 0 to 2 right now, right, in most organizations. Think about how you're going to break out of that and get to the next level. And finally, we believe the way to path towards that is governance, thinking through how to give freedom to those application teams, how to define all those hundreds and hundreds of rules and regulations in a consistent manner. To automate them, you have to understand them more deeply than you ever did when they're in a document or someone's head. Set up that protection for those teams and the infrastructure to really empower and drive them forward and enable them. And finally, that starts to drive education as they learn more and more from how it worked, what went wrong, what to do next. That creates that positive feedback loop where you can guardrail them enough to let them experiment with things as exceptions, so you can learn together and then keep going around. Okay. So that's everything I wanted to cover. I'm happy to take questions if anyone would like to ask one. And thank you very much for your time.